Hello everyone. We are diving into one of the most critical parts of being a responsible AI leader, monitoring for bias in real time. In professional terms, real-time bias monitoring is the continuous automated observation of an AI system's outputs to detect and mitigate disparate impact or unfairness as it occurs in a live production environment. In simple words, it's like having a digital fairness referee who watches every move the AI makes while the game is actually being played. You've probably seen this at the office, where a tool works perfectly in testing, but once it meets real customers, it starts acting differently. I once worked on a project where an AI was supposed to fast track customer service tickets. In the lab, it was great, but once it went live, we realized it was accidentally ignoring tickets from people using older smartphones. If we hadn't been watching in real time, those customers would have been left in the dark for weeks. Now that we understand that we can't just set and forget our ethics, we need to look at the specific yardstick we use to measure if everyone is being treated fairly. To keep our digital referee objective, we use a concept called disparate impact, which is a legal and statistical doctrine used to determine if a neutral policy or AI model disproportionately affects a protected group, even if there was no intent to discriminate. To put this in simple terms, we are checking to see if the final score is fair for everyone. A very common way to measure this is the 4/5 rule. Stay with me here because the math is simpler than it sounds. If your AI is approving loans for 100 men, it needs to be approving them for at least 80 women to be considered fair by this standard. If that number drops to 50, your real-time monitor should be screaming at you. It's like a smoke detector for discrimination. It doesn't care why there is smoke, it just tells you that the house is getting too hot. But even when the final numbers look okay, the AI might still be making mistakes in a lopsided way, which leads us to checking our error rates. Sometimes the problem isn't who gets yes, but who gets a no by mistake. This is where we look at equalized odds, which is a fairness metric requiring that the model's false positive rates and false negative rates are similar across all protected groups. In simple words, the AI should be equally wrong for everyone. Let's break this down together. Imagine a security AI that flags suspicious behavior in a store. If the AI is 99% accurate overall, but it makes 10 times more false alarms for younger shoppers than for older ones, that is a huge bias issue. In our real-time dashboard, we don't just look at the total accuracy, we look at the oops rate for different groups. If the AI is going to make a mistake, it shouldn't keep picking on the same type of person. Now, seeing these mistakes in a chart is helpful, but in a fast-moving business, we can't wait for someone to check a graph, which is why we need to set our boundaries. To turn our observations into action, we establish bias thresholds, which are predefined numerical limits that, when exceeded, trigger an automated notification or a system override. In simple terms, this is setting the alarm bells for fairness. You've probably seen this with bank alerts on your phone. In the AI world, we tell the system, if the approval rate for people over 60 years old drops by more than 10% compared to younger people, send an urgent alert to the Chief Privacy Officer. I've seen teams ignore bias because they were too busy to look at the data every day. By setting these alerts, the data comes to you. It forces the organization to stop and look at the why before a small ripple becomes a giant wave of bad publicity or a lawsuit. But even with alarms going off, you need to know exactly which part of the AI is causing the problem. When the alarm rings, we have to perform feature attribution analysis, which is a technique used to identify which specific input variables are contributing most to a biased output. In simple words, we are looking for the troublemaker in the data. Sometimes an AI learns to be biased by using a proxy variable. For example, it might not know a person's race, but it knows their zip code or what school they went to, and it uses that to discriminate indirectly. By monitoring these features in real time, we can see if the AI has suddenly started relying too heavily on a piece of data that it shouldn't be using. It's like being a detective and realizing the AI isn't judging people on their credit score, but on what time of day they shop. Once we find the troublemaker, we have to decide how to fix it without breaking the whole system. The final piece of real-time monitoring is the human-in-the-loop override, a governance requirement that ensures a qualified person can review and reverse a biased AI decision before it impacts a real individual. In simple words, it's the kill switch for unfairness. If our monitor shows that the AI has suddenly developed a bias against a certain group, a human should be able to step in and say, "Stop, we are going to handle these applications manually until we fix the model." This is what separates a good company from a great one. Governance isn't just about watching the problem, it's about having the power to stop it. We never want to be in a situation where we say, "We knew it was biased, but we couldn't stop the machine."